Okay, section 1.4 is about solving absolute value equations. And we need to review the definition for absolute value. Absolute value of a number is its distance from zero on a number line, which means absolute value is always positive. So we know that absolute value is always a positive number because distance can never be negative. Remember the symbol for absolute value are the absolute value bars. Okay, so it looks something like this. So there's two types of problems that you're going to have. One is just evaluating an absolute value expression, and then one is solving absolute value equations. So here are the basic steps when solving absolute value equations. First, we're always going to have two problems to solve when we have absolute value bars involved. And the reason for that is, just like this example, if I want to know what x can be, the absolute value of x is 2, well, x could be -2, or x could be a +2. So that's why when absolute value bars are involved in an equation, we will always have two equations to solve. Our first step would always be to isolate the absolute value. So I'll show you what that looks like. And then set the problem equal to the original problem and it's negative. And then we're going to solve. And anytime we solve absolute value equations, our answer will be a number set. So it will be our answer, let's say our answer was 2. We're going to put our answer in brackets, saying that the answer set or the number set for that problem is our answer in brackets. All right, so let's look at example 1. Example 1, we're going to evaluate, which just means they're going to give us numbers to plug in, and then we're going to come up with our answer. So I have 8.4 minus the absolute value of 2 times -7.5. I'm plugging that -7.5 in place of my n, plus 5. And when we evaluate expressions, we count absolute value bars the same way we would as parentheses. So we have to follow the order of operations. So I have 8.4 minus absolute value bar, 2 times -7.5. So 2 times -7.5 should be a -14 plus 5. Okay, so now we're going to, oops, I added 14. That should be 15, sorry. So I'm going to change that to 15. All right, so 15, -15 plus 5. And now I'm still only doing what's inside my absolute value bars. -15 plus 5 is -10. And now I still do only what's inside the absolute value bars. I'm not going to say minus a negative makes a positive. Okay, I'm going to bring it over here. I'm going to say 8.4 minus the absolute value of 10 is now a positive 10. So now my signs are different, so I need to subtract these. So 10 minus 8.4. Okay, so I need to borrow. That makes it a 9, 6. So it should be 1.6. And it's going to be negative because my 10 was bigger. So negative 1.6. Let's do another one. Example 2. All right, in example 2, I'm going to plug -2/3 in place of my y. So I have 1 1/3 minus the absolute value of 2 times -2/3 plus 1. Okay, so now I'm going to do what's inside my absolute value bar. So I have 1 1/3 minus 2 times -2/3. So when we multiply fractions, we multiply straight across. So that's going to be -4/3 plus 1. Okay, so now I still do what's inside absolute value bars. 1 1/3 minus -4/3 plus 1. I'm going to find a common denominator. My common denominator is 3. So if this is 1 over 1, that 1 over 1 would change to 3 over 3. So I have 1 and 1/3 minus negative 4/3 plus 3/3 is going to give me negative 1/3. Now I'm going to do my absolute value. 1 and 1/3 minus the absolute value of negative 1/3 is positive 1/3. So now 1 and 1/3 minus 1/3 is 1. So you have to be really careful and follow the order of operations and do absolute value bars first. Okay, so now we're going to do some examples when solving absolute value equations. So because the absolute value of a number is always positive or 0, an equation like the absolute value of x equals negative 4 can never happen. I can't say that the absolute value equals a negative number. So sometimes this will happen, and when this happens, there's no solution. Okay, so you're going to say the solution set for this type of equation is called the empty set. So when you solve something and you get an equation like this that's not true, your answer is going to either be the brackets with nothing in it, showing that's the empty set, or this symbol, a 0 with a line through it. That's the symbol for empty set. You can't just put a 0 because if you put a 0, that means you got 0 as the answer. The other thing when solving absolute value equations, you sometimes get what is called extraneous solutions. See this word extra? Extraneous solutions means you have an extra answer that doesn't work. So that's why when solving absolute value equations, you have to check your solutions. And I know you're not going to like that, but it has to be done because you're going to get extra answers that really don't work. So let's do example 3 real quick. Absolute value of 3x minus 2 plus 8 equals 1. So our very first thing we're always going to do is isolate your absolute value. That means anything that's not within the absolute value bars, you're going to get rid of. So the first thing I'm going to do is subtract 8 from both sides. So now I have 3x minus 2, or the absolute value of 3x minus 2 equals negative 7. So after you isolate the absolute value, I'm going to look at this. I have the absolute value of something equals negative 7. Can this ever be true? No, we just said that the absolute value can never equal a negative number. So my answer to this is the empty set. There are no solutions, which means there's not any number I can plug in for x to make this a true equation. So your answer either needs to look like this or the actual empty set, the brackets with nothing inside it. Okay, so let's do example 4. Example 4, solve and check. So the very first thing is we need to find our absolute value bars and make sure that it's isolated, and it is. Okay, so there's nothing I have to get rid of that's on the same side of the absolute value bars. So my second thing is it equal to a negative number? No, it's not. So now I'm going to write my two equations. I have x plus 10 equals 4x minus 8. So your first equation is your original equation without the absolute value bars. Your next equation is going to be x plus 10 equals, and now you always write the total opposite of what you were given. So I was given 4x minus 8, so I'm going to write negative 4x plus 8 because it could also equal the negative of whatever this number is. Okay, so you always change your signs on the other side. So now we have two equations to solve. So I'm going to solve this one first. Okay, I'm going to get my x's on the left-hand side. So I'm going to take this 4x and move it over. So I'm going to subtract 4x from both sides. Negative 3x plus 10. My 4x's cancel, and I get negative 8. My x's are on the left. I want everything else without an x over on the other side. So I'm going to get rid of this 10 by subtracting 10 from both sides. Negative 3x equals negative 18. Divide by negative 3. So x equals, I have a negative divided by a negative. So that's going to be a positive 6. So that's one possible answer. Okay, now we're going to do the same thing over here. I'm going to bring my x's over to the left-hand side. So I have a negative 4x, so that means I'm going to add 4x to both sides. 1x plus 4x, 5x plus 10 equals 8. Subtract 10 from both sides. 5x equals negative 2. Divide by 5. X equals negative 2/5. Okay, don't change this to a decimal, just leave it as negative 2/5. So what we need to do now is we need to check and see, does one answer work? Do both work? What am I going to use as my answer? So you have to check these, okay? So when you check, somewhere either next to the problem or underneath it, you're going to put a check mark, and then you're going to show me the work that you checked. So here's how you show your work that you're checking. I'm going to take my answer, and you always plug it back into the original problem. So I'm going to take 6 and plug it into both of these x's. So I have absolute value of 6 plus 10 equals 4 times 6 minus 8. So I have absolute value of 16 equals 24 minus 8. Absolute value of 16 is 16. 24 minus 8 is 16. So I know that's a true equation, so I know that 6 definitely works. Now let's try negative 2/5. I'm still taking that and plugging it back into my original equation. So absolute value of negative 2/5 plus 10 equals 4 times 2/5 minus 8. Okay, so I'm going to have to find a common denominator here. My common denominator is 5. So my first fraction stays the same. My second fraction, 1 times 5 will give me 5, so 10 times 5 is 50. Equals, I'm multiplying fractions, so I have 4 times 2 is 8 over 5 minus 8. Now, we can stop and look at this. I know that this is going to equal a positive number. 8/5 minus 8, is that going to be a positive number? No, it's not. So I know that 2/5 cannot work. Okay, so here's the last example. Example 5. First thing we're going to do, oh, I need to go back for a second. Let me make sure I did that one. I need to write this answer as a solution set. So the solution set is 6. Okay, we're going to put our answer in those brackets saying that it is a set. Okay, last one. First thing we're going to do is isolate our absolute value. So you always add or subtract first. So I'm going to add x to both sides. So now I have 2 times the absolute value of x plus 1 equals 3x plus 1x, 4x minus 4. Now I need to isolate my absolute value by getting rid of this 2. This is 2 times that, so I'm going to divide everything by 2. So now I have absolute value of x plus 1 equals, divide this by 2, so 4 divided by 2 is 2x minus 4 divided by 2 is 2. So now we have our problem. Now we're going to rewrite our 2 problems. So my first problem, x plus 1 equals 2x minus 2. It's always your original problem without your absolute value bars. My second problem is x plus 1 equals the opposite of what's on the other side. So negative 2x plus 2. So now we're going to solve. I'm going to bring my x's over to the left-hand side. Negative 2x. I'm going to subtract 2x from both sides. So 1x minus 2x, negative 1x or negative x, plus 1 equals negative 2. Subtract 1 from both sides. Negative x equals negative 3. And if negative x equals negative 3, then positive x equals positive 3. So that's one choice that might work. Over here, add 2x, add 2x, 1x plus 2x, 3x plus 1 equals 2. Subtract 1, 3x equals 1. And so now I divide by 3, and I get x equals 1/3. Okay, don't divide that out, leave it as a fraction. So now we need to check. Either 3 or 1/3 is going to be our answer. So when we check, here's my check mark. We always put it back. I'm going to put it back into this original equation. So I'm plugging 3 in place of all of these x's. Okay, so I'm going to say 2, 3 plus 1 minus 3 equals 3 times 3 minus 4. I'm plugging 3 in place of all of these x's. So I have 2 times the absolute value of 3 plus 1, which is 4, minus 3 equals 3 times 3 is 9 minus 4. So now 2 times the absolute value of 4, that's just 4. So 2 times 4 is 8 minus 3. Okay, so that's good. We know that 3 is going to work. So now I need to check, and I'm going to write up here, 1/3. So I have 2 times 1/3 plus 1 minus 1/3 equals 3 times 1/3 minus 4. So I have 2 times 1/3 plus 1. Isn't that just 1 and a third? So I'm going to write it as 1 and 1/3 minus a third equals 3 times. A third minus 4, you can find a common denominator if we want. So 3 is my common denominator. This is 4 over 1. So 1 times 3 is 3. 4 times 3 is 12. 2 times 1 and 1/3. 1 and 1/3, isn't that the same thing as 4/3? So I'm going to write 2 times 4/3 minus a third equals 3 times 1/3 minus 12/3, negative 11/3. So now 2 times 4/3, multiply straight across, an absolute value, it's going to be positive. That's 8/3 minus 1/3 equals, when I multiply this, do you see that my 3's will cancel? And I get negative 11. Is 8/3 minus 1/3 going to be negative 11? No. So I know 1/3 is not going to work. When we write our solution set is going to be 3, and it's going to be in the brackets. Okay? All right, so your assignment will be given to you in class tomorrow.